Hi, today we have the question longest arithmetic subsequence from DP itself. So, in this question, we have given an integer array nums. We have a nums array. We have to find the length of the longest arithmetic subsequence. Okay, so arithmetic subsequence is not like a subarray. Okay, we are not looking for contiguous elements. We just find the subsequence. The elements must maintain order but can be non-adjacent. So we want the longest subsequence such that if we subtract a nums I from nums j, if we take the index 1 as I and 0 as j, then it should be equals to if it is in the subsequence of arithmetic progression, then it should be in uh, like order of uh, nums of I minus nums of j is equals to nums of k minus nums of I. So it should follow an order. Okay. So the differences should be same. So we can define each arithmetic subsequence by a pair of element and their difference if we are going through tabulation approach. But first we have to think about the recursive approach. So how we can think about its approach? What can be its intuition? So let me first think about the recursive approach or we can say a brute force approach. Okay. The core idea is to try every possible arithmetic subsequence and find the longest one. Okay. How we define a possible arithmetic sequence? Like it is defined by its first two elements. Okay. If these elements are in AP, then the first two elements are 3 and 6. Okay. So once you have the first two elements, say nums of j and nums of I, the common difference is nums of I minus nums of j. Okay. Like from here, we just have to extend the subsequence, or we can say a sequence that maintains the same difference. Okay, this is our logic, and we have to go through it. So, what we do is we will pick a starting pair, okay, and it iterate through all the possible pair of elements. Okay, so first we will take the 3 and 6 and we will iterate how many elements are there in this difference. Okay, like the first two elements are 3 and 6, they have difference of 3. And if other elements containing, if we compare their difference from the 6, if that will comes to 3, then they will also be in the subsequence because they are following the order. So we will recursively extend. Okay, we will recursively extend. How we can extend? Just look at our code. We have our code for the recursive approaches. Like we have a recursive helper function. Like its purpose is to find the length of the arithmetic subsequence, and it starts at index I with a common difference of def. Okay, it has a length. What it is doing, like it initializes the length and it is starting from 1 because nums I, we are taking nums I from here, the nums I, and we are taking the index as I. It is already in the subsequence, it is already in the subsequence, and we are calculating from the nums I, so we are taking length as 1. And if we find any another element which has the same difference, we will just add 1 to the length. Okay, this is our whole approach for the recursion. Okay, like here what we are doing is if we find any number with the same difference as of, like what we are doing here is we have two for loops nested, and we are taking I from n minus 1 because we are just going iterating from the last of the array. So we are going from last n minus 1 uh, to the 0, okay, not including 0. And the j, we are starting from the I minus 1th element and we are going to the 0 and inclusive 0. So what it will do is uh, I is the, you can say, upcoming element, and j is the uh, it comes before the ith element. So we will compare the difference. What will be the difference between them is nums of I minus nums of j, and we will just pass the difference and I index to the recursive our helper function. So what does our recursive function doing? When we are finding the same element, what we are going through is we are just starting from 12 and 9. We are picking 12 and 9 as our the first pair of elements, pair of arithmetic progression. 9 be a first element, 12 is the second element, and after we will find the element which has the same difference as the 9 and 12 has uh, after the 12. If we find any element after the 12, beyond 12, then we will include it in our subsequence. Okay. Okay, let us take an example of 6 and 9. We have a difference of 3. And when we have taken 6 and 9, we just go beyond 9 and see if we find any element which has the same difference when we subtract the elements from the base element, that is 9, we have the difference 3. So we will just add our length, okay, and return it. Okay. So what we are doing here is we are just finding an element after the ith index, after the ith index. If we find the same difference element, then we will just add the length, and we are making the length maximum of length and the current length. Okay. And then we will just do is return the length. So this code uses a brute force recursive approach. Like it is the without memoization code. It iterates through every possible pair in the array, and to define the starting subsequence and the common difference for each pair, like it is then recursively it is then recursively searches for the longest chain of the subsequence element that maintains the difference. Like this method is simple to understand, but it is highly inefficient because it is using a recursive function, two for loops. So this the time complexity for this function goes for the exponential. Like it is an exponential complexity, as we can see on. Uh, so after the brute force approach, we have a recursive plus memoized approach. So it is called top-down approach. How we can make our recursive code more efficient? Like we are just making an unordered map. Like what is this unordered map? It is just an um array of unordered maps. Like for every unordered map, for every unordered map, it will just have the every subsequence until that index. If we go in array and if we find any index in that array, then we have a map which is recording the every subsequence with the different differences uh, for which are following different orders till that index. Okay, what is it is doing? It is just an array of unordered maps. So here also we are doing same as our recursive approach. We are just picking the two elements, okay, and like first two elements of any subsequence, and we are just calculating a common difference. And from there, we are trying to extending the subsequence as far as possible, and we are doing it by just calling the recursive function, and we are just keeping track of the longest subsequence we are finding, and we are just passing it to the max length, and we are returning the max length. Like how is the optimization performed here? Okay, it is also a naive approach. We will calculate the same thing in the bottom up approach after this code. Okay, what we are doing is we are not uh, like uh, calculating the you can say subsequences twice and repeatedly again and again, we will just store the like all the subsequences and with their differences in an array of maps. Okay, like what we are doing here is we have a variable max length as we like already had in the recursive approach, and an unordered map of like array of unordered maps. And if I'm taking the dp of I of difference, it is storing the length of the longest arithmetic subsequence that starts at index I and has a common difference diff. Okay, I am repeating again. The dp of I of difference will store the length of the longest arithmetic subsequences that starts at index I and has a common difference diff. Okay. So what these loops are doing, as I had already told you that these are just picking the two starting elements. Okay. So we will just store, we will just store how we can find that subsequence for that difference is existing or not. We will just go to that index, and if we find any subsequence for that difference, we will just return the dp of I of difference, and we will just pass length, how like the length we are calculating from the recursive approach. We will just store it to our dp array of unordered maps. Okay, this will have the time complexity of big of n square because of the two nested loops. Okay, and recursive call which are memoized, like we are not doing any extra work, and space is also big of n square. And we will like in dp table, the worst will be the we are just storing n into n entries, so this will be the worst case. Let's go to the bottom up approach now. It is the most efficient way to solve this question. What we are doing is we are just like iterating from, like we are taking two nested loops here also. It is efficient because we are not making any recursive calls. We are not making like there is no calling stacks. So it is more efficient than the memoized approach. So what it is doing, like it is just iterating our whole array from 1 to n. Okay, 1 to n. Why we are iterating I from 1? Because we have to pick two elements, so we will take j from 0. Like if we take j from 0, then it will be like going uh, from j to I. So we will find the subsequence from 0 to the I for every I. Okay, for the every I, and we will store it to the DP. Like it is the same DP we have used in the memoized approach. How we are calculating, like how we are storing the DP, let us see. Like as we have done the difference, how to find the difference in recursive in memoized, and the same we are doing here also. And as I already told that we are taking length is equals to 1 because we are just starting from I equals to 1. So we are taking that element also because we are starting our subsequence from, if I take an example, then if we are going from 3, if we are going from 3 or from 6, we are including that 6, so that would be included in length already. So we are taking our length as 1 at the initial. Now I will show you what we are doing next. So I have taken length as 1. Then if we have dp of j, like till j, if there is a count, if there is a count, like count function just gives us that the element exists or not. If the element is not exist, then it will return 0. If element exists, then it will return 1. It is not counting the number of elements, it is just returning the uh, if the element is existing or not. Okay. If we find count of difference till the array, like till the array index j, if we find, then we will just pass it to length. Okay. We will just pass it to length. It is the same as we have done in memoization approach. Like we will, like what we do in memoization, we just find if the DP is, like the DP has the solution for the existing the call, then we just return that index from DP, and we are just filling the I of difference as 1 plus length. Why we are filling the I? Because till j we have already find the length, and now we are moving towards the next element. Then we are taking I because I starting one more less than j, so we will fill our I dp of I as length plus 1, because when we are iterating to the next element and which has difference same as the previous pair, then we will just add the length to 1. Okay, then we are just passing the max length. Okay, and we are returning the longest subsequence. So this is the bottom approach. I hope it is easier. So if you like the video, just subscribe to my